Hi coders, CS Time channel here, and this time we will talk about Introduction to Recursion. This video discuss about definition of recursion, syntax of recursion, and recursion examples. Recursion is a way of solving a problem by having a function calls itself until some terminating condition is met. It works by breaking down the problem at hand into smaller subtasks. Here is the syntax. We start by naming the function as well as return value and parameters, and then check for the stopping condition or base case. Otherwise, it will call the recursive function. Here is an example. In a factorials, for example, we have n factorials. It means n times n minus 1 times n minus 2 times n minus 3 and so on. And if we plug it to a number, for example, 5 factorial, it means 5 times 4 times 3 times 2 times 1. The same to 4 factorials, 3 factorials, 2 factorials, and 1 factorials, and also for 0 factorial defined as 1. Now let's see how to write it in function. To write it in a function, let's examine this equation here. If we take a look at this, n factorials equal to n times n minus 1 times n minus 2 and so on. If you take a look at this part, it's basically equal to n minus 1 factorial. So n minus 1 factorial equal to n minus 1 times n minus 2 times n minus 3, exactly the same as this. From here, we can conclude that our equation can be like this: n factorial equal to n times n minus 1 factorial. Let's see it further. If we check 3 factorials, then equal to 3 times 2 factorials. Then if we check for 2 factorials, equal to 2 times 1 factorial. And if we check 1 factorials, equal to 1 times 0 factorials. If we check 0 factorials, equal to 0 times minus 1 factorial. Here we have a problem because minus 1 factorial is not defined. So from here, we can conclude that the equation that we have work only when our n greater than equal to 1. So we can conclude that when n greater than equal to 1, then the equation is n times n minus 1 factorial. Otherwise, it means our n less than equal to 0, then n factorial means equal to 1. If n, which is 3, greater than equal to 1, then we will use this equation, which is 3 times 2 factorial. And for 2 factorials, we will also still use this one. It means we use equation n times n minus 1 factorial. The same for 1 factorial. When n equal to 0, so 0 factorial here, then it will run this n. Now let's translate it into a function. At first, you need to write the name of the function, which is factorial here, and then we need to return the value, and then the parameter that we want to take, which is the number that you want to calculate, and then here we check if our n greater than equal to 1, it means this, then we will return n times call again the function. Otherwise, when n less than equal to 1, then we will return 1 here. This we call it as base case or terminating condition, and this one we call it as recursive case. Let's see the complete code in Java programming. The first step here is to write the recursive method. We will just copy the one we wrote just now here like this. I'll make it bigger, and to be able to run this, then now we need to create the object for the class like this. We will ask the user to input the number for the factorial like this, and to be able to do this, we need to use scanner like this, and then to be able to use scanner, we need to import Java util, and now we can enter the number from the user like that. Now we can call the recursive method like that, and we can display the result like that. Now let's run it. Okay, enter a number, for example 5 here, and then factorial 5 is 120. So here is the logic. When we run it, it will execute the object here, and then it will display this here and then ask us to input the number we did, and then we call the recursive method. Then it will go here. It send the 5 to this, and then we check 5 greater than equal to 1. Yes, then this will be execute, and which is 5 times factorial 4. Since this is means calling the method, then it will go here, run again. It checks now. Factorial is 4 greater than 1, correct? Again, run this one. This time will be 4 times factorial 3. And then again, this one, it means calling the recursive method. Then it will call again 3 here. And then it check again here, 3 greater than 1, correct? Then it will execute again this one, 3 times factorial 2, and then call again factorial 2, and then check here 2 greater than equal to 1, correct? Then call again 2 times factorial 1, and then call again factorial 1 here. Now it's already 1 greater than equal to 1, correct? Then it's going to be 1 times factorial 0 here, and then call again here. Now the n becomes 0 greater than equal to 1. No, it will execute this one, return 1. As soon as it return 1, that it will calculate the result. Let's see the second example here. Now we will see Fibonacci sequence. Here is example of Fibonacci sequence. The first two numbers is 1, and then 2, 3, and so on. If you are looking for Fibonacci n, for example here Fibonacci 2, it means the second number of Fibonacci, which is 1 here. And then if you are looking for Fibonacci 3, then it's 2, and so on. Now let's see the relation between the numbers. From this sequence, we understand that to get 2 comes from addition of 2 previous numbers. The same with 3 means addition of 1 and 2, 5 addition of 2 and 3, and so on. So we can write the equation like this. Fn, n can be any number, is equal to Fn minus 1 plus Fn minus 2. So if you want to know F5 or Fibonacci 5, it comes from Fibonacci 4 plus Fibonacci 3. The same with Fibonacci 3 comes from Fibonacci 2 plus Fibonacci 1. And then Fibonacci 2 comes from Fibonacci 1 plus Fibonacci 0. As you can see here, for Fibonacci 5, there's no problem because we have Fibonacci 4 and 3. For Fibonacci 3 also, there's no problem because we have Fibonacci 2 and 1. When we want to know Fibonacci 2, it comes from Fibonacci 1 and Fibonacci 0. Fibonacci 0 is not defined here. So this formula doesn't work for Fibonacci 0. And the same, if you are looking for Fibonacci 1, it comes from Fibonacci 0 plus Fibonacci minus 1. Fibonacci minus 1 is also not defined. So our formula only works when our n greater than equal to 3 up to here. From this, we can conclude that for Fibonacci n, if n greater than equal to 3, then the equation that we use is Fibonacci n minus 1 plus Fibonacci n minus 2. Otherwise, when n less than equal to 2, then it should return 1. Let's translate it into a function. So we need the name of the function. Here is Fibonacci, and then we need the formal parameters to take the value, and then we need the return value here. And then we should check if n greater than equal to 3, then the function should call itself by putting this here, Fibonacci n minus 1 plus Fibonacci n minus 2. Else, it should return 1 here. This one we call as base case, and this one we call as recursive case. Let's see the complete code in Java programming. The same with factorial number program. Our first job here is to write the recursive method. We just need to copy paste it here from the one that I just explained just now. And then now we need to write the complete code. So here in the main method, we need to write the object for the class like this. And then we can ask user to input number for the Fibonacci like this. And then to be able for user to enter the number, we need to write a scanner here. We need to create the object for scanner like this. And then to be able to use this, we need Java util like that. Now we can hold the value entered by user like that. Now we can call the recursive function there. Now display the result here. Let's run it. Enter a number, say for example 3 here, then the Fibonacci number for 3 is 2. Okay, let's see the logic. When we run the program, then it will execute the object for the class and then ask for the user to enter the number here, and then once we enter, it hold under n here, and then we call the recursive function or method here. So we enter 3 here, then 3 will go there. As it enters the method, it will check 3 greater than equal to 3. Yes, true, so it means this will be executed. Fibonacci 3 minus 1, it means Fibonacci 2 plus Fibonacci 1. Look, Fibonacci 2 here, it means calling itself here, so it will execute again Fibonacci 2 greater than equal to 3. No, then it will go here 1. So the result for Fibonacci 2 is 1, and then the other one is Fibonacci 1. Fibonacci 1, that it will call again here, then Fibonacci 1, and then it will check 1 greater than equal to 3. No, then it will execute this one. Once execute this one, then it will calculate the value. Previously Fibonacci 2 is 1, and then Fibonacci 1 is 1, then 1 plus 1 is 2. So the result is 2 like this. If you learned something from this video, please subscribe and like for more videos. Thanks for watching.